Hey folks, welcome back. This is Joel, and we will continue with our discussion on network automation. Uh, in the previous video, we actually we did a bit of whiteboard with respect to some key concepts like the data format, right? The network automation data formats. I mean, it's not just network automation in any kind of software development. You will probably come across these, right? So the various data formats. We talked about why do we really need network automation. We talked about the various APIs available to us, which is SNMP, Netconf, Restconf. We talked a little bit on the differences between programmability and automation. We went a little deeper into and then we talked about Ansible, right? And then we looked into the checklist, right? um, a checklist of items which you probably would need to set up your own dev environment. That being said, today we will actually dig deeper into what? We'll dig deeper into the stuff which I promised in the previous video, which was mainly around the network APIs, right? And it's very important to do that because most of our discussions going forward would be around this, right? So network APIs. Awesome. So that being said, when we talk about network APIs, right? So we have SNMP, Netconf, and RESTconf. SNMP is old school, so we're probably not gonna do anything much there. So we'll start with the Netconf and RESTconf. But before that, let's actually do a little bit on actually this particular session or what we are going to do today or in this video. It's mainly going to be around three concepts, right? Let me just put that down here. So it's going to be around Yang, Netconf, and your RESTconf, right? So these are the three things which we will look into. Right, that being said, let's start with the first one, which is my Yang, right? So Yang, very important thing to remember is it's a data model. It's not a data format, right? And why I say it's a data model is because like I can't define a random, I can't use a random structure, um, say using XML or JSON or whatever format, right? I can't define, uh, I can't use a random structure because both the devices involved in the communication, right? When we talk about Yang, we are mainly talking in terms of Netconf and RESTconf, right? So whenever two devices are involved and they are exchanging the information using one of these protocols, right? They really need to exchange the information as per a predefined structure, right? So let me show you an example. So here from a Cisco, config guide, I can see here what they're trying to do is they're trying to configure SNMP traps, right, using Netconf, right? Now, when you're doing that, like I talked about in the previous video, in a Netconf exchange, you generally have a client, you have a server, right? And both of them need to support, or both of them will be talking using the Netconf protocol. We'll dig deeper into Netconf later, but just to give you an idea here, right? You can see here the client seems to be telling the router to do something, or the switch, whatever the device is, it's trying to tell something. It's trying to, you can see a RPC call going here, and inside the RPC, it's telling the device to edit the config. And when I'm telling someone to do something, right, that particular, the target device should understand that, right? So it should be able to refer to this particular Yang model, which it has, right, on himself or like on that particular device, right? So it's able to, it should be able to, look up this particular model which is present on the device and then take actions based on what values I have sent, to the device. Like for example, here I'm, configuring some kind of traps, right? So when I'm using these tags and when I'm configuring this particular traps, the device should be able to understand this. And how it's going to understand? Only by referencing to the model which is, already present on the device. So that is the reason why you need a data model and you can't use a data format here, right? The data format is still used. You can see the XML is there outside, right? But then inside the XML, you see we are sending the RPC call, and this RPC call is invoking the Yang model. And for the Yang model, we are basically sending the various values, right, inside for the Yang model over here, right? So that's all. That's how all the various parts, come together, right? So if you want me to like put it down here, this is how the various pieces would come together, and that's a confusion which many people have, right? So at the topmost layer over here, right, you're probably going to have some kind of an API, right? Or let's not confuse that. Let me just uh, say some kind of a, you know a programming language, right? Let's make it easier. So you have a programming language let's say like Python, right? Not restricted to this. I'm just giving an example of the whole stack which is involved, right? Then you have your protocol, right? The programming language like Python, right? Inside the Python, you'll be writing a script which is going to, you know, talk using a particular protocol, and that protocol is either going to be something like Netconf, right? Or it can be something like Restconf and so on, right? Pretty straightforward. Now, the protocol is good, but you need some kind of an encoding, right? This is where your data format comes into picture. Let me use that red color here just to highlight this. So this is data format, right? And this is where you have stuff like your XML or JSON, right? But that's not the end, right? Now the most important part is the model over here. The next one is the model, the data model, right? And that's where your whole yarn comes into play. So this is your stack, right? This is how when you're building a script, when you're doing any kind of automation, this will be your stack. You're going to have some kind of a script. I mean, you can write it in any language you want. I'm just giving an example, Python, which is going to interact, using, it's going to interact using something like, netconf, restconf, like a protocol, right? And then the protocol itself, internally, it uses some kind of an encoding, like netconf uses XML, restconf uses, JSON, right? So it's using some kind of a encoding, and inside that encoding, right, it has to reference some kind of a model. Because why? Because we want both the devices to understand each other, right? It should be a standardized, centralized model, right? So that's the reason we use something like an YAML, right? So hope that's clear. That's a full stack. Now, that being said, let's dig a little bit deeper into Yang. I want to give you an example of how the whole Yang looks like, right? So I believe I pulled out one of the example here. So you can anytime go down to the netconfcentral.org. This is like your Bible for your whole, Yang models. All your Yang models are present here. You can browse them, you can check them out and do all of that, right? So I've just pulled out a very simple Yang model, which is for your IETF interfaces, right? You probably will find all Cisco specific or any other vendor specific models as well. That being said, let's just concentrate on the structure over here, right? You start with something like a module name, and the rest is mainly, who wrote this, what is the description, why this was written, what is the revision, and all of that. So the meat of it starts from here, right? So whenever you see a container, that's where the meat of it starts, or the most important pieces start, right? Now, if you see here, there are probably going to be multiple containers, or in fact, before the container, let's look at the type def, right? So probably I suspect there are going to be probably multiple type defs here. Yeah, so there are two type defs. Yep. So one is your interface, ref, interface dash ref. So this is the data model that needs to reference interfaces. And the other one probably is going to be for the data model that is needed to reference the operationally present interfaces, right? So there are two separate, type defs which have been defined, right? So once you go inside the type def though, that's where your containers start, right? I don't think, in at least in most of my use cases, I've mainly used the interface ref. I've not used the second one I mean, I'm pretty sure there might be use cases for that, but mainly I have always restricted myself to using interface ref. So let me just explain this particular type def, right? Now, if you go inside the type def, like I said, the most important part is your container, right? So you have the container. Container is kind of like grouping a bunch of leaves, right? So always remember leaf to be the smallest unit in a Yang model, right? So you have a leaf, and in fact, you'll have a bunch of leaves, right? So if you see, let's do a bottom-up approach right over here. So like I said, let's go down till this container. I'm not sure where it ends. Yeah, see, this is the place where the first container ends. So you see inside that particular container, you have a lot of leaves, right? You have a leaf for detecting when the last change happened. You have a leaf for the admin status of the interface. Is the interface enabled, right? So a lot of these leaves. So these leaves roll up to what we call as a list, right? Why? Because on a device, it's not that you're going to have one single interface. You're going to have multiple interfaces, right? And these various interfaces, right, which are part of the list, are then roll up to a container at the top, right? So that is generally the structure. Again, I'm not saying this is always going to be the same, right? If you really don't want to, if you on a device, if you don't have multiple, instances of that unit, then you probably will not have a list. But I'm just taking an example here, right? So don't assume that the same, Yang model or the same format will be there across everywhere, right? So that's the main part, right? You start with container, you go down to something like list, and then inside the list you're going to have your leaves. Now if you look into the leaves, you're going to have various let's call it key value pairs itself, right? So you see there is a list, and just like every list has some kind of a list, is like your, if you're trying to connect it back to Python, you generally have list, and you want to identify a particular list, right, using a unique identifier. Now in a Python environment, or in a Python context, you basically identify the list, individual member of the list, using some kind of an integer value, right? Like list of 0, list of 1, list of 2. But in this case, or in case of Yang, we kind of reference it using some key value. So here you're gonna have a key for the list, and then again a description of what that list is going to be. But then individual or the individual members of this list, right, are going to be, because you can have again multiple lists inside the container as well, right? So when you're coming from top, you would wanna reference this particular list. And how do you do that? Using this particular key. But once you're inside this list, you're going to have multiple leaves. How do you reference each of the leaf? So there you would be using the leaf name, right, or the leaf description, and so on, like whatever the unique values are identified for that, right? So that being said, you can see there are a lot of again let me just use the word key value pairs, or maybe something like data types. Here you can have some data types, like for example, we are explicitly saying for this particular leaf, the data type is going to be string, and we are also putting in a description down there. This is pretty much the same thing, I believe. Okay, that was leaf name, and this is leaf description, right? So you need to define the type of the value, right? That particular leaf is going to have, right? Here you can see it's a very good example for Boolean. Is it true or false, right? And so on. You'll also sometimes find enumeration. Enumeration is used when you really know what are the possible values which that particular value or that particular leaf is going to contain, right? In this case, it is pretty straightforward that the admin status of an interface can either be up, or it can be down, or it can be in the testing phase, right? You'll also sometimes find these two interesting things. One is the config, and the other one is mandatory. Config is when you explicitly know that this particular leaf cannot be configured. Like for example, admin status, right? You really can't configure. It's just there on that device just to show you, the status, right? Mandatory again, just tells you that yes, is this leaf really mandatory, right? Is this configuration really mandatory or not on a particular device? So that being said, so these are the various leaves, right? Now the second container, you see, we have the second container starting here, which is the container statistics. Now I would, when you're talking about statistics, it's again something which you can't configure, right? Statistics are basically present on the device to help you to do something, to help you to kind of, second, they're just present out there to help you to show you some values, right? So that being said, so that was a very very quick view into how generally a Yang model looks like, right? So the next piece which I want to talk about here is, or let me just try to make a note of everything which we discussed, so that's it's easier to put in, over here. So let me try to put stuff over here. Give me a second, right? Just to put in an example, right? So what we discussed was for interfaces, I believe. So you start with something like a module, right? And it's going to have some name, say something like interfaces. It might not be exactly same. I'm just putting it here for reference purpose. Then you have something like a container, right? In fact, we saw that there were two containers. So there was one container for, I think, interfaces, if I'm not wrong. There was, and the other one was for statistics, right? Basically talking about the state of the interface and so on, right? Now under this, each of this container, you're probably going to have something like list, because why you're going to have list? Because you're going to have like multiple interfaces, right, on a device. And under that list, you will have some unique way of identifying this list, because again you can have multiple lists under the container, right? So this one you can reference using some kind of a key value pair, right? And once you're inside the list, now you would want to have kind of like a leaf, right? And this is where you can have multiple leaves like this, right? And each leaf will further have some kind of a will further have some kind of a type, right? Telling what is the data type allowed for that particular leaf, right? And the various key values which it can hold, right? It's going to have like type. It's going to say, can this be configured? Is this mandatory? And so on, right? So this is generally a very simple example. I just wanted to put it down here. So it's a very simple example of how your young model would look like, right? Again, this is not something frozen. It might be different for different modules, like slight changes might be there, but this you should get the idea, right? This is generally the structure. You start with something, start with the module name, and then you have go down to the containers. You can have multiple containers. Containers kind of like house a specific functionality, right? For example, at the top, it's for housing a particular functionality. Here at the bottom, it is trying to say these are the statistics which you can get from an interface, right? And those are housed under this container, right? And under, like I said, you're going to have some kind of a list. Then you're going to have the unique identification for the list, and each of the value or each of the unit of a list is basically a leaf, and each of the leaves can further have some data types and the various values which it is going to hold, right? All right, so that being said, let's just see if we can run some kind of a script here so that I can show you how the whole interaction happens. I mean, I do have a quick lab which I have set up, using CML, but we'll probably park this when we are talking netconf. Let me just go down to my environment and see if I have I think this is a pretty interesting script, right? So I have a script here. What it is trying to do is, um, I will again look into the script and all of that, like each and every functionality later. But then just to give you a quick glimpse, right? What this is doing is this is connecting to the sandbox, device, right? Sandbox, like I've explained in my previous video, you have all these devices which are always on 24/7. So this is iOS XE device with this particular username and password, which is always on. So you can try it out as well. So what we're trying to do is we have a netconf filter. Filter is basically to tell that, okay, don't give me everything, just filter it out and give me only this information. That's basically, in fact, here we are basically telling, give me the information corresponding. This is the same young model. Remember, we went through just now. So it is trying to look into that young model and trying to get the information only for this particular interface, which is gigabit Ethernet, 2, right? So it is just trying to get us that information. Excuse me. So that being said, if I run this now, you will probably see the output. So this is one of the reason why I like VS Code, right? This IDE, because now I can like I think I probably talked this earlier as well. I can quickly switch whichever Python environment I want. You see it has returned. The output is present here, right? So what we were trying to do is, let's just skip to the bottom, because at the top we were trying to look at the capabilities of netconf and all of that, so which we will discuss later. But if you see at the bottom, the last part of the output here, and if you see here as well, what we're trying to do is we are now able to get the information for the interface, which is gigabit Ethernet 2. We are able to get the description, right? We were able to get the description for that particular interface, right? And we earlier probably saw how the description of the interface is present inside the leaf, right? So just to connect back here, if you look here, we have called the particular, I mean, we obviously called the netconf filter, which was right. So let me probably go from the top, right? So what we did here is we basically sent that RPC request, which I showed you earlier, the XML part on the top, right? So we basically sent it over here, and the response what we got was the interface Python, right? Which is probably the whole thing here, right? The whole order dictionary which you got here, which is like a direct dump of everything, but that's of no use for me, right? I really need something very specific. So what I have done, what we have done here is, we once we have obtained the whole thing, we are obviously we are printing the interface name down here, but then you can see we have divided the whole output into two pieces here, right? We have divided into the configuration of interface as well as the operational state of the interface. And you see there are two containers, right? This is one container which is interfaces, the other container is interfaces dash state. If you go back here, you will find, so let me just do container interfaces. See, this is one of the container. The other container is going to be interfaces dash state, right? See, this is the other container, right? So we are basically literally digging deep into the container. We are referencing each of the container, and so this is basically helping you reference the container. We are going one step inside that and basically calling out the leaf right over here, right? The interface leaf under that. So if you again go back here, you basically see this one, right? So in fact, we are basically calling out list, right? This particular interface, right? So once we did that, now this is the reason why we used this filter over here, right? Because on a device, if you don't use this particular filter, right, you probably get all the interfaces on the device. But since we specifically said or told the device to return back only information for gigabit 2, right? That is why our response is also going to be having only the information from gigabit 2, and that's why it is very easier for me now to directly reference, right, the name of the interface, which is gigabit ethernet 2, the description over here, which is present over here, and also the operational state statistics. We are also referencing the operational state, which is helping us obtain the packets which were input and output and all that, right? So hope that kind of gives you some kind of an idea on how we can use the Young model, how we are using the Young model over here, calling the Young model, and this Young model is obviously going as part of the RPC, right? Which is the RPC, which is in this case would be basically to get config, right? You can see probably somewhere down I would have referenced the get config RPC. Let's probably see. I think it should be somewhere down here. Yeah, see, right? So it's using the get config part. So and we are using the netconf filter here mainly because we want to filter out the output only for a particular interface, and we don't want the whole. If you don't probably give this, then what is going to happen is you're going to get the output for the whole set of interfaces, right? And this is going to be a huge output. Then you'll have to figure out a way in your code, to kind of like loop through the whole output to figure out this particular to figure out the config and operational state for that particular interface, right? So to make your job easier, the kind of you also get an option in netconf where you can kind of like filter it out, right? So we'll see a little bit on the code later as well, but I just wanted to give you a glimpse of how the whole framework or the whole architecture like fits in, right? You have Yang on one side, you have the RPC, you have XML, all of this. How does it fit into the whole model? All right, so that being said, I also want to take this time to kind of show you a couple of cool tools to help you to build these Young models, right? Because there will be chances where you will have to build forget building, right? Even to use the Young model. I mean, we picked something very simple, which was interfaces, but there might be opportunity for you to kind of work on some different Young model, maybe something related to routes and so on. So there are two interesting resources. One is your Young catalog, right? youngcatalog.org. You have probably you can I normally go to the Young search option here, and you basically get to search all the Young models which are there. Like for example, I want to search something with respect to routes, right? And I can if I just hit the search button, it's going to give me a lot of outputs because the word routes is probably going to be there everywhere. So you can filter it here. Like for example, if I want to get all the Young models which have the word routes mentioned somewhere in the module name, right? I'll probably go and hit the search over here, and it's going to return back with only those Young models, right? Probably there was nothing with that. Let me go back. Probably let's change it to maybe along with the node name. Let's also get all the Young models with the um, which is going to have like yeah. So there you see, you have all the Young models which are listed. In fact, probably this one might be the one which I'm really interested with, right? So then you can obviously click on this and try to get more information on how the Young model is written, right? The basic containers and everything which we just now saw can be obtained here, right? So this is like your quick way to kind of see if there are already Young models which are written for that particular. You can also find platform specific or vendor specific Young models as well, right? Awesome. So that's one thing. The other piece is also probably you can check this out. This is also something which I have used in the past. If you click on the tree view, it's something very, very useful, right? So looking at the whole Young model which I was showing here, it becomes very difficult because when you're looking something on the top, you probably, or when you're looking something on the top, you would have bottom, you would have already forgotten what you checked on the top. So because you have so much text in between. But if you're using this, the tree view, it's very easy, right? So you can just use the clickables over here, and you can see all the various leaves which are part of that container, and so on. So all of this, becomes very, very easy when you want to quickly. So you see, there's a symbol for the leaf over here, and it becomes very easy to kind of see what is. You can see this is a container, right? This particular instance is a container, and inside the container you have a leaf, and this particular leaf is nothing but a data type of string, right? So everything becomes very easy to have a look at, in one single place if you're using the tree view. The other interesting piece which I also want to show here is another interesting tool called as the Young Explorer, right? It's present down here on GitHub, again open source tool. It's a pretty easy to install as well. It's not supported on Windows, but probably on Mac, Linux, and everywhere. It's a GUI based tool, right? So they've given a very interesting, they've given a very detailed steps to install this. But let me actually show you how it looks, because I think I've already installed it on my system. So it's probably down here. Yeah, so there you go. So it's basically, think of it like, you need to obviously have some prerequisite, which is Python. In this case, you need to have Python 2.7 for this to work. But once you install it, it is going to run on some kind of a like a HTTP server, right? It's going to run on this particular server, right? Always use this link. It's again going to be shown to you when you run it. But so this is the link, and I have logged over here, and you can see, um, what I've done is, what you can do here is, right? So you obviously log in. Generally, it is a guest. I think the username is guest. The password is also guest. But it has a lot of functionalities. Like for example, I believe I've created a device profile, right, which is for my device, which is something like a CSR device, right? I was testing it probably on one of my lab devices earlier. Now it can't be established because this particular device, I have removed the configuration. That's why it's not able to establish the connection, but that's fine. Maybe we can try this out later, but I just wanted to show you how this looks like, right? So if you want to quickly build some kind of, maybe we can go down to build over here. If you want to build some kind of RPC, right? Because like I was telling, it becomes very, very intensive to build your own XMLs, right? If you look at this code, let's go back to the code over here. It should be somewhere here, right? So I was showing you this code earlier, right? The RPC, the XML RPC request, right? Basically the filter, right? Now, if you want to build a custom RPC RPC request, it becomes very tedious to kind of build this on a text file, on a text editor like Notepad or something, right? Because you need to know all this information. But that's where your Young Explorer makes it very easy, right? You can build an RPC request. Again, since I don't have anything, probably it's not going to show. But you can build, like for example, on the left hand side, you can see I'm showing you an example for the IETF interfaces. So I can now drill down to each of this, probably select this, and go down to the value and say I want to create a IETF interface with the description, say bits please, right? So I can do something like this, right? And once I do this, this particular, right? So once I click on that, and I mean once I edit this, I can go and click on RPC over here, and you can see the RPC request gets generated on its own, right? Now you can obviously you can even run this directly from here, from by clicking on the run button over here, because if this device was working, I probably would have shown you. I really don't have this device working right now, but then you can do that, right? You can run it from the comforts of this button, right? And it's going to give you the response and all of that. Also, the other stuff is you can also generate your own Python code, right? See, there you go. We have a sample Python code which got generated to do that particular task for you, right? So you can generate a Python code, and you can like leverage this Python code in any of your other scripts. That being said, you also have capabilities, right? So again, it's probably not going to work because my device is not running right now. But capabilities, what it is trying to do is it will show you all the various netconf capabilities on a particular device, right? So you can now understand what is supported and what is not supported. So it's like a one-stop tool to help you with your Young development. When you are working on a project which involves a lot of netconf and Young, right? Pretty interesting tool. All right, so that being said, now let's go back to our the drawing board here. We have talked a little bit on the Young. but the meat of the whole conversation is your netconf and restconf, right? Because those are the protocols which will be using this YANG. In fact, netconf will be the guy who will be using. So let's just double click a little bit on the netconf part as well. So when you're talking about netconf, right? Again, I think probably I touched a little bit of base on this earlier, but to just to recap that, right? It was around 2006 when that particular RFC came into, or when the RFC was kind of like built, I would say, about for this particular protocol. Yang, in fact, came around, I believe, 2009 or 2010, right? Later, quite later, right? And the RFC of that as well came quite later after that, right? Now, some very interesting pieces about Netconf. One of the interesting attributes of Netconf is that it is, let me start drawing maybe the stack. I think that'll be useful. So, just like any protocol, right? Netconf has what you call as a transport layer. And what is the transport layer? SSH. It uses our traditional SSH, for Netconf, right? Netconf basically uses the same thing. So it has all your authentication and all those capabilities which SSH brings to the table, right? Apart from that, on the top, this is I would basically call this as the application layer stack, where, it's going to use your XML, right? And we have already discussed for the message exchanges, it is going to use your RPC, right? So some kind of RPC request, RPC replies, and all of that. And at the top, what are those RPC requests? It's going to be something like this. It's going to use something like get config, edit config, and so on, right? A lot of such RPC. I mean, those are the operations which are carried out by your RPC requests or replies. And then again, one more, probably I mistook this, so I need to put one more here at the top. That is where your Yang models, right, or the data, actual data, or the Yang models are basically used, right? So always remember this particular stack, right? It's very important. So the stack is basically pretty simple. So you have the transport layer here, and the layer at the top is basically, you always need to look this bottom up approach like this. So you have the transport layer, and then the stuff which goes on the transport layer, the actual meat of the data, right? The actual data, it is going to be encoded in XML, right? Every single thing is encoded in XML. You have three important pieces here. One is the RPC. The messages are basically going to use the RPC calls, right? And what kind of operations are possible? That is basically your get config, edit config, and all of that. And the content, the actual content, right? Where we are saying what config do you want, or on an interface, what do you want to actually change, right? All the values and all of that would basically be referenced inside the Yang models, the actual data, the Yang models, which I probably showed you here, right? A simple example probably here. You can see here. Yeah, these are the values which I was talking about, right? So that's your stack. That's your whole Netconf stack. Okay. That being said, now I think it's been too much of a lecture kind of a thing. Let's go and so like I said, I have a small lab here. So I want to show you how we can go and enable Netconf and probably try out maybe a script here to test it out as well, right? So let's do that. So let's go to my CML over here. You see, this is pretty straightforward. My Ubuntu machine is residing here, and I have a simple switch without any configuration. It's just there so that I can add more devices in future. And this is the device, the CSR 1000 is the device on which we'll be configuring, right? So that said, let's go down here. Let's click on Open Console. I like really CML. It's pretty handy, simple to use, and all of that. Right. So let's go here and let's start configuring. Let's put in some basic stuff, right, on this device. So let's go and first let's go to line console and probably this put it logging synchronous, otherwise it's going to be very annoying. Let's put in a host name for this guy, right? So the host name is the CSR. Okay, that should be fine. It's a CSR 1000 box anyway. Let's put in the IP domain name, right? So probably something like I don't know, abc.inc or something like that, right? And what else? We will also need to create some users, right? So let's go and create a username Cisco. The privilege, right, is also Cisco. So let's say privilege and then password. Cisco, right? So that should be fine. And what else? What else do we need here? Now the next thing is you need to create your keys, right? Because for your SSH, right, you will basically be using this key. So you need um, the crypto to be present up there. So crypto, I believe it is key generate RSA. Um, I think by default it is 1024. I'm going to keep it 1024. And what else? Let's go and enable SSH because, like I was telling, for Netconf, the protocol, underlying protocol, transport layer protocol is SSH. So I'm going to use that. I've enabled SSH. Let's enable it on line VTY 0 to 4, I believe. Right? There you go. And transport input, right? I need to again SSH. Right? There you go. So that's done. Now let's look at the connectivity. You see this particular device is connected using the gigabit Ethernet 1 over here. So let's go to that particular interface. Gigabit Ethernet. Okay, I think I need to come out of here. Interface gigabit Ethernet 1. And under that interface, let me put in an IP address, right? The IP address which I'm going to use is basically my host on the network. So it's 192.168.221.11, just so that it is, we can connect to it from where? From my Ubuntu machine, 255.255.255.0, I believe, right? Into a notepad here. Let's just quickly check if it is reachable. Looping 192.168. I think 221.129 is probably my Ubuntu machine. Yep, there you go. My Ubuntu machine is reachable. What else do I need here? I believe we have taken care of everything. Okay, so now to enable netconf, right? You just have two commands. One is netconf SSH, I believe. There you go. The other command is netconf yang. So you have to explicitly enable yang as well. There you go. So we are done. Let me just do write memory here. So we have saved the config, and now we can go back to our Ubuntu machine and try to connect to this guy, right? First, what we could do is we could use that Yang Explorer which I was showing you guys earlier, because that'll be fun to see if it really works. So this one, right? So what I'll do is let me show you the. I think this is perfect. The host name is correct, port is correct, Cisco. So now when I hit the capabilities, you should see it should be able to connect. Okay, maybe. There you go. It took a bit of time. So anyway, so you see, just by clicking on these capabilities, I was able to connect my Ubuntu machine over here to the switch, which to the CSR device, right? And we were able to get all the capabilities or all the Yang modules which it supports, right? See, you can see here, all of the ones are listed down here, right? So that's pretty cool, right? And if I this is what I was telling, right? Like if I want to generate an RPC, right, it's pretty much straightforward now, right? I can define which interface I want to configure, and I can just by clicking on this, right? So here this is basically doing an edit config, right? Similarly, I can do a get config and all of that. So this is a very interesting tool, so that for you to like connect to your device to understand the capabilities, to test probably some RPC calls, see if it is really configuring it to run, and you can also save it as well for in collection. Just like you can think of this like a postman for Netconf, right? So yeah, that being said, let's go back to and run few scripts here. All right, so that being said, what we'll do is I have a bunch of scripts here just to show you how all of this comes into play, right? I have kept I just picked these scripts from the code exchange, right? I have not edited any of this. So uh, you can always probably go back to this and change the router credentials and all of that to your own environment. Like in my case, my environment is currently CML, right? So I can change this router host name to the IP address of my in fact, I can do that right now just to show you that it really works, right? So or maybe let me run this first, because what this is doing is it is listing out the capabilities on the sandbox device which is there on Cisco DevNet, right? So if I run this, let's run it without any kind of debugging. It's going it's going to give you like a huge output here, see, which is going to list out all the netconf capabilities, right? All the modules which it is going to support. See, explicitly the module names are listed down here. You probably will find a lot of IETF modules. You also probably will find a lot of Cisco specific modules as well, right? You can see everything which starts with cisco.com, and you'll also probably find a lot of IETF modules. At the top you can see there are a lot of IETF modules. Let me just, yeah, here at the top there were a lot of IETF modules, and then you have the Cisco modules, right? Now just for your satisfaction, I can show you what I'm going to do is, let's just replicate this and probably put in the stuff for my device, which is 192.168.221.11. The port is 830, right? I mean 1000 is, I mean 10,000 is the one used on Cisco DevNet. We are using different, so this is going to be Cisco. Password is also going to be Cisco, right? And let's just get rid of this one, right? So if I save this and if I run this now, it should basically do the same thing, but it should run for my device, right? Which is my CML device, which is my own lab. Okay, so I think probably need to scroll down a bit. There you go. So we have it's still running. Okay, there was an issue. My bad. I think I put in an I over here. Let's just run this again. Right, there you go. I think I had made a mistake here as well with the IP address. Just be careful with the IP address and the port. So 192.168.221.11 is the IP address on my CSR device in my lab, which is CML lab. And you can see it has returned with all the capabilities which are activated or which are available for me to configure, for me to play around, using Yang models on my own device, right? So that's pretty straightforward, right? So now let's probably look into some of these interesting scripts which people have written. So, right, so let me just pull this up here. Yeah, so let's look at another example. I think probably the script which I'm highlighting now. Let me just clear the screen so that you know the exact difference in the output. Anyway, so this is, I think this is script which we probably ran earlier, but let me just give you an example, right? I mean, explain, right? So we have a bunch of import statements here. We're importing the NC client which is needed as manager, and we are putting in the information regarding the router credentials and all of that, right? See, this is the sandbox device, and you have the port, you have the username, password, and all of that. Further, you have defined a netconf filter, right? So that is another very good advantage of netconf, is that it gives you the feature to define some filter inside your RPC, right? You're basically saying, hey, don't give me the information, or don't provide me information for the whole set of interfaces. In fact, give me information only for gigabit Ethernet 2, right? And then you're connecting to the, using the manager object, you're connecting to the netconf server, which is nothing but your router in this case, the CSR 1000V. Then you're printing out the various capabilities, right, which are present on that. And then you're kind of like running this specific so once you're connected, once you've obtained all the capabilities which are there, what we are doing is we are trying to get the running config, right? So you can see here, this is what I explained earlier, right? We are basically calling this particular netconf filter, which we defined earlier, right? We are basically calling that netconf filter, which is nothing but XML, right? So we are calling that, and we are sending that information as part of the RPC reply, right? So whenever a device talks to a netconf server, initially there'll be some kind of an hello messages exchanged, right? Basically, again, nothing but the RPC messages itself, right? But the whole idea here is you don't want the whole configuration out there, so you are making a cautious decision of creating this XML, right, which you created here at the top, right here, netconf filter. The netconf filter got converted, or kind of like got referenced here while the get operation was committed, or when the get operation was done using netconf, right? So that as a result of that, basically the interface netconf is going to have information only pertaining to gigabit Ethernet 2, right? That being said, as you scroll down, like I was telling, here we are using the XML to dict, kind of like a library to convert the XML into dictionary, so that it's easier for us to use it going forward. So here you can see the whole dictionary will be printed. Maybe let me run this while we are explaining, so that we don't waste time, right? So the whole dictionary is going to be printed, right? So once we have the whole dictionary, You can see here, this is the dictionary which I was talking about. The ordered dictionary got printed, and then we are now trying to reference the exact interface name, right? So using that dictionary, so you're going deep down into the dictionary. So if you look at this whole dictionary, you'll probably get an idea. Dictionary is nothing but Python, an object for creating the key value pairs, right? So that's why you're referencing, you see in the code, you're referencing the interfaces, you're going deep down into interface name, and you're referencing the text of that interface, right? So you get the interface name, which is displayed here at the bottom. You just scroll down here, this is the interface name, and the next is you're printing start, just as I identified, I believe. But then you can see, like I explained earlier, we have two containers here, right? Inside the interfaces Yang model, we have two containers. One is your interfaces, and other one is called as interface state, right? So interfaces basically talks is the container which you use in order to configure the IP address and the admin no shutdown and all of that, whereas interfaces state is more like a read-only kind of container where you can get only the statistics out of it, right? So that's why you see here, we are reading the name and the description from the first container, right, from the config container, and the second container, which is the operational state, right, which is giving me information about the packets, and that is basically listed down here, right? So that was again a very simple example of how you can connect to a device using netconf and do your automation, right? um, cool. All right, so the last part of the discussion will be on restconf, right? We did yang, we did netconf, we looked into some examples. The last one which I want to spend a few minutes is on my restconf, right? So what is restconf? Basically it is, go down here, there we go. So the restconf, when we talk about restconf, it's also, let me again use the same stack which I was explaining earlier, right? So you also have a stack here at the transport layer. The difference between restconf and netconf basically comes here, which is at the transport layer it is HTTP protocol, right? In your if you see at the top, the transport was SSH, right? But here you're basically going to have at the transport layer, you're going to have HTTP, right? So the next is here, since you don't have any kind of RPC, right? You don't have any RPC requests and all of that. So let me try to kind of create a very similar model as earlier. So I would say this, you can just divide into just two pieces here, right? Which is right. So you're going to have only two pieces. One is your, when it what kind of an operations you're going to commit, because the HTTP inherent has some operations, right? Like get, you're going to have post, put, delete, and so on. So there are a lot of operations which are given by your HTTP transport protocol itself, right? So we are basically reusing those, right? And we don't have to, no there is no RPC here, right? We don't use RPC. Instead of RPC, we are basically using these operations. And then the content, at the content layer, I would say 99% of the time here, right, we use JSON, right? 99% of the time we use JSON, but then XML is also supported here, right? If you want to kind of like do restconf, basically if you want to kind of like send a HTTP get post request using XML, right? Possible, it is technically possible, but probably not many people would use it, because creating XML is difficult while creating JSON is pretty simple, right? So now that being said, we could try out some examples. So what I have is this is where our postman comes into picture, right? So you see there are a bunch of examples here. So postman, let me just tell you some cool things about postman. Here you can create environments, right? So you can see there are a bunch of environments which I have here. In fact, if you want to see the iOS XE environment, you can see here, right? So this is the credentials of the sandbox environment again. So you have the host name, the port on which restconf is running, you have the root username, and then you also have the password, right? The you can create these environments, and then you can, whenever you're running a particular call, you can select which environment you want to run, right? So now if you want to see some basic stuff, right, like for example, let's run the module state. Let's see what this is going to return, right? So there you go, it gave me the module states, right? Basically these are the various netconf, give me a second, right? So these are the various RESTconf modules, the REST API calls, right, which basically are present here. So you can see probably I missed explaining this part over here. Just like your Netconf, you also have, since it is HTTP based, you don't have to send it via your RPCs. Rather, you're gonna send it via your GET request. And this information you get it from the documentation again, right? So if you want to get the information about all the modules which are supported, you can use this particular call, and it's gonna return all of this. From an authorization perspective, you just use the username and password, right, for the device. Basically like your HTTP authentication. Headers, probably you can see here I'm accepting JSON, right? But like I said, you can also change this to XML as well, because XML is supported. But again, I don't think anyone would use it because it's a little difficult to read and create and all of that, right? Body, there is not going to be anything unless we are doing some kind of a post, so we'll probably check that out as well. Now we can check the second call, which is like getting the interface information, right? You can see here it is getting the interface information using this particular REST call, and it's obtaining its JSON format, right? The return type is JSON format, and you can see all the interfaces which are active are basically returned, right? So that's pretty cool. So we have loopback 0, 101, 337, and so on, which is pretty cool. Now you can also, I'm going to show you another call here just to show you the routes, right? You can get the routing table. Right, there you go. There is some kind of a VRF, this kind of a default route which has been put on this device and that information. Now that's cool. All of this is cool. Can we do some kind of a post or something like that? So what I'm going to do now is, um, always remember when you're using the Cisco sandbox, right? Like you are doing any change on the sandbox, it's cool. I mean, you can go and check out, you can, do some configuration, but always make sure that when you're exiting the sandbox, remove the configuration of the box, right? Otherwise, it's probably going to create trouble for the folks. So better to keep it clean, do all your testing and then remove it, right? That being said, let's all right, actually before we head to that, let me actually show you one more interesting piece, which is about getting the capabilities, right? Even RESTconf, at the end of the day, they use all these YANG models, right? It's just that they don't use the XML way of getting it, rather the JSON way of getting it, right? So if you want to look at all the modules or all the capabilities, I mean, what we looked here was modules, but if you want to look at all the capabilities, all the YANG models explicitly, you can have a look at here, right? So you can see this is the same output which you would have received earlier when we ran those capabilities and using the netconf Python scripts as well, right? So just to kind of like double stress on this, we are basically using the same YANG models, to reference the data. It's just that here we have made it more easier by removing the RPC calls, and we have included all of this in the existing HTTP methods, right? That's the only difference. And obviously, RESTconf doesn't have any kind of transactions like your NetConf has. Like you have a connection open because it is mainly HTTP based, right? Because NetConf is more SSH based, and which in turn is like TCP. So it's more of a transaction based, whereas this guy HTTP is stateless, right? So cool. So that being said, what do we do next? No, we will. Okay, so this is the other piece which I wanted to show you, which was till now we just looked at get. How do we post something, right? So when we talk about post, we need to add something. So for example, I'm adding a description to an interface called, let's probably add it to an interface called interface 31 maybe. And I'm assuming that interface doesn't exist. So interface, loopback 31, and I'm putting in some kind of a description called bits please. I'm pretty sure no one would have done it by now. So let's, I'm hoping no one deletes that by the time we verify it. So let's run this. So you see I did get 201, which means now I can go to probably get interfaces and see, or get interface loopback. Let's run this, right? Let's see if this one probably gives us the value. Let's run this and see what is returned. Right, there you go. So we should see the description. Awesome, right? So we created an interface and we kind of put in the description as displays, right, which got reflected. So we literally went and added an interface to the sandbox Cisco server, right, Cisco devices. Now as a good practice, always go and delete it. So in my case, I'm going to go and delete the one which I just now created. So there you go. I should get a 204. Okay, there you go. So it's no longer going to be present, right? So that was mainly with respect to RESTconf and how you can play around. Let me also show you how to enable the RESTconf, right? That's because that's pretty important as well. So if I go back here, not sure where is my right. So there's nothing much you have to do. You just need to go and let's go in there. So you just go inside that and write restcon, and then obviously you'll have to, because it's all based on HTTP, you'll have to enable say HTTP server. Let's enable IP HTTP secure server as well. And the other one is let's enable authentication as well, right? Because you want some kind of authentication, and here it's going to be authentication local, which is the local username password which will be used, right? So now what we'll do is just to end this particular session, let's we have seen how we can interact. We have seen how we can interact with the RESTconf using Postman. Let's also run a simple script as well, right? So I have a simple script over here. Let me just get rid of this. So you see, I have, let me just clear the screen. Okay. So I have a very simple script with the credentials of my own CML router, right? This is my IP address, the port, username, password, and it's a very simple REST call over here, where we are, basically calling the REST call where we are trying to obtain the information for gigabit Ethernet 1, right? And we are basically printing the description. I don't think there is a description as of now, so probably it will return empty, but let's see. So if you run this, you can see the output. Here you go. So the interface seems to be up. That got printed, right? The interface seems to be up, but there is no description because I have not put any description on the interface, right? I can actually show you that, right? Let's see if our stuff is working. So let's go to interface gigabit 1, and let's put a description, say um, bits please, right? So now that I've put that, if I go back to my script and if I run the same thing, there you go. You can see bits placed now, right? Which means it got reflected, right? So that's how you can interact with the your REST conf as well using your Python scripts. Awesome. So okay, let's just quickly review on whatever we discussed today, right? That's pretty much what we discussed. We started with Yang, Netconf, and RESTconf, right? We talked a little bit on Yang. We looked at the Yang model for interfaces, interface configurations, right? We looked at that, and we also defined this is how the module would basically look like, right? You have containers, you're going to have lists, you're going to have leaves inside it, and so on. You can also go and check that out in the Netconf central URL, and you'll probably get a loads of young models to play with. Then we also looked into Netconf. We defined the stack, how the stack looks like. Remember, Netconf always uses SSH. And then RPC and obviously the Yang models on top. Whereas RESTconf kind of differs with respect to that. It doesn't again go into the whole RPC and all of that. Rather, it tries to use HTTP protocol, which is very common protocol, and it uses the various methods which are provided by HTTP instead of all this RPC. Right? There is no RPC calls in RESTconf. Rather, we use the get, post, put, and all those methods. And at the data layer or the content layer, I would say it uses generally 90% of the time probably uses JSON, but you can also make it to use XML if needed, right? And obviously it's all of this ties down to the Yang models, right? Both of these protocols basically tie down to the Yang models, which are already defined and which are basically built day in and day out by vendors as well as by the IETF, right? So thanks for watching. I think we have set up a pretty good base for our future discussions on network automation, right? We did a quite extensive kind of like a review, I would say, on various topics here. And I think do watch out for more videos in future where we discuss more cool stuff. Thanks a lot. Have a good day.